Hello dear optons, welcome to our channel Ni&La Online. In this video, we are going to discuss about physical optics. We already learned about physical optics in our high secondary schools. This video only consists of the important topics which is needed for our future videos in optometry. There are many applications in optometry which uses the principle of physical optics. Physical optics. The branch of optics concerned with dual nature of light. The physical optics subdivided into two, wave optics and quantum optics. Wave optics deals with the wave nature of light and quantum optics deals with the particle nature of light. Wave optics. Wave optics treat light as a series of propagating electric and magnetic field oscillations. Phenomena based on wave optics include interference, diffraction and polarization. Interference. Interference is an optical phenomenon in which two waves superimpose to form a resultant wave of greater, lower or same amplitude. It is subdivided into two based on the way of superimposition. Constructive interference and destructive interference. Constructive interference, it occurs when the maxima of two waves added together. The resultant intensity of the wave is greater than the sum of the intensities due to separate wave. This diagram is about constructive interference in which maxima of verb 1 added with maxima of verb 2, but the resultant intensity of the verb is greater than sum of the verb 1 and verb 2 intensities. Then second one is destructive interference. It occurs when the verb superimposed with their maxima of one verb correspond to minima of other verb. The resultant intensities are lesser than the sum of intensity due to separate verbs. This diagram is about destructive interference in which maxima of verb 1 correspond with minima of verb 2, but the intensities of the resultant verb is lesser than sum of intensities due to verb 1 and verb 2. Application of interference, anti-reflection coating on the spectacle glasses which use the principle of destructive interference. Optical coherence tomography, laser interferometer, interference filter and holography. Diffraction, it is a slight bending of light when it passes around the edge of an object. The amount of bending depends on the wavelength of light to the size of the opening. Depending upon the distance between light source or screen and obstacle or aperture, it is divided into two, Fresnel diffraction and Fraunhofer diffraction. Fresnel diffraction, which is also known as Fresnel-Kirchhoff diffraction. In Fresnel diffraction, either source of light or screen or both are at finite distance from the diffracting device. Diffracting device consists of obstacle or aperture. Fraunhofer diffraction. In Fraunhofer diffraction, both the light source and screen are at infinite distance from the diffracting device. Application of diffraction. Causes of visual symptom, glare and halos. Set a limit on visual acuity by forming blur circle. Set a limit on resolution on optical instruments. These are the application of diffraction. Then polarization. Polarization refers to the orientation of vibration of light wave. When vibrations are mostly in one direction, the light is said to be polarized. In this diagram, the unpolarized light is vibrated randomly in different direction. But after going through a polarized filter, the light rays only vibrate in one direction, vertically polarized light wave. Application of polarization. In ophthalmic instrument for controlling unwanted reflection from cornea, Heidinger brushes phenomena to record and reproduce three-dimensional pictures, Polaroid sunglasses, Titmus flight test for measuring thickness of retinal nerve fiber layer, detection of defect in intraocular lenses. Next, quantum optics. Quantum optics is considered light as a particle and concerned with the interaction of light and matter. Phenomena based on quantum optics include transmission, reflection and absorption, scattering, photoelectric effect, laser and fluorescence. Transmission, reflection and absorption. When light incident on a surface, a number of things could happen. Some portion of light reflected back, some portion absorbed and transmitted into another form of energy, and only the remainder portion of light is transmitted. Reflection, when light is incident upon a polished surface, some of light is bounces back. Absorption, it is a process by which light is absorbed and converted into different form of energy. Transmission, passage of light through a medium after reflection and absorption. Scattering, deflection of light rays from straight path due to irregularities in incident surface. Shorter wavelength scatter more than larger wavelength. Laser, laser is an acronym for light amplification by stimulated emission of radiation. Laser device stimulate atoms or molecule to emit light at a particular wavelength and amplify it to produce very narrow beam of radiation. Fluorescence, it is the emission of light by a substance that has absorbed light or other electromagnetic spectrum. For more videos, please subscribe our channel Ni&La Online and also put your valuable opinion in comment section. Thank you.
Subscribe now and press the bell icon. Never miss an update.